out okay. These first four formulas up here, the sum and difference formulas, are the ones that you were deriving in your Desmos activity today. So just in case you didn't have yours word for word exactly how they are in here, you can see how the book writes them. I mean, the book uses U and V instead of X and Y anyway. So as long as you have that concept, I wanted you to experience how we could derive that formula rather than, here's the formula. I think it adds something extra on when you could see it being made. Would I have ever come up with that on my own? No. But somebody did. There are two other formulas that did not show up in our Desmos activity, and those are tangent, sum, and difference formulas. We're just going to use whatever we need to answer these questions. First question, find the exact value of cosine 75 degrees. So for cosine 75, I don't know that one because that's not a 30, 60, 90, 45 value. But I can use the values that I know and rewrite 75 as a sum or a difference. So for cosine 75, I'm going to rewrite that as cosine of 30 degrees plus 45 degrees, because that's equivalent to the cosine of 75. So that is a sum. I'm going to use the cosine sum formula, which says to use cosine 30 multiplied by cosine 45. And then it says subtract sine 30, sine 45. So once I've plugged those in, I can find the value of cosine 30. Anybody know it? 1/2. Cosine 45? Radical 2 over 2. Sine of 30? Well, how is that possible? You guys all told me this was 1/2. So you were wrong? We should know these very well. It is radical 3 over 2. I was writing down what you all were saying. Okay, so once I have those replaced, the word cosine and sine, those are gone. I just have their values. Now I can just multiply and subtract. So that's going to give me square root of 6 over 4, subtract square root of 2 over 4, and they already have a common denominator, so square root of 6 minus square root of 2 over 4. Remember, if we have different radicals, we cannot subtract them. They're not like terms. So we have an exact value for the cosine of 75 degrees. Find the exact value for sine pi over 12. So sine pi over 12 is radians. So I'm going to think about radians that I know. I know pi over 3, pi over 4, pi over 6, pi over 2, and others. If I change their denominators to be 12s, how can I get pi over 12 using the angles that I know? Christopher? Right, I can subtract the pi over 4 minus the pi over 6, right? Okay, so I'm going to rewrite this as sine pi over 4 minus pi over 6. So we need our formula, which you guys derived. And it says to do sine u cosine u minus cosine u sine u. So I'm going to have sine pi over 4 cosine pi over 6 minus cosine pi over 4 sine pi over 6. So I'll plug my values in. I'm going to simplify it, and I get square root of 6 over 4 minus square root of 2 over 4, which is square root of 6 minus square root 2 over 4. So that would be the exact answer. And you may notice it is the same answer as the one previous, but they are not the same measurements. What is pi over 12 like as degrees? It's 15. So up here we had the cosine 75. This is the sine of 15. Shouldn't they be the same answer? Because they'll be in the same triangle. Okay. Now, not all answers are the same answers. So this one, find the exact value of sine 42 cosine 12 minus cosine 42 sine 12. So I look at this and I'm like, I don't know the sine of 42. We have to find the exact answer, meaning don't use your calculator. So we're going to use our formulas. This one looks like it's one of them that was expanded out. What I notice is this one starts with sine cosine. So only the sines start with sine cosine. And that example also has a subtraction in it. So it's got to be sine u minus v. So I'm going to rewrite this as sine 42 minus 12, which is sine of 30 degrees, which is half. All right, the next example, write cosine arctan 1 plus arc cosine x as an algebraic expression. So we're using cosine, and it's a sum. So I'm going to use the formula from the first page that says to do cosine of the first angle times cosine of the second angle it's not plus though. The cosine is like opposite the sine. So if it is a plus, it ends up being a subtraction. And then I do sine of the first angle multiplied by sine of the second angle. So when we see arc tangent or arc cosine, what am I getting when I do arc tangent or arc cosine? What is that representing? Well, it is the inverse, but what does the inverse give me? Yes, it does give me a restricted amount of answers, but what are those answers? What are they? They're angles. So the arc tangent and the arc cosine, these are angles. Just like x and y were angles, just like u and v are angles. These are angles. So I'm doing the cosine at the angle that is equal to arc tangent 1. So we got to find the angle of arc tangent 1 first. So tangent is limited to negative pi over 2 to pi over 2. This is positive, and it's equal to 1. Sorry. What angle is that? Bless you. What angle is that? That equals tangent. That makes tangent equal 1. What angle does that? Gavin? Mm-hmm. Pi over 4. So this would be like saying cosine at pi over 4. Over here, I'm going to skip this cosine arc cosine x just for 1 second. Over here would be the same thing as sine at pi over 4. Okay, we also have to figure out this arc cosine x. So cosine has the values from 0 to pi. And this says what angle has a cosine of x. So since that's not an actual number, I can't find the angle. I'll just call it theta. It's that theta right there. There it is. So I'm just going to put cosine theta. And over here, I'll put sine theta. Now let's do our next step, which is what is the cosine at pi over 4? Okay, what is the cosine at theta? So go look in our picture. What's cosine for that picture? X. Minus. What's the sine at pi over 4? And what's the sine at theta? The sine is not 1. So if x is the x side, the radius would have to be 1. I didn't hear what you said, hon. Oh, yeah. So we're going to have to use Pythagorean theorem. We'll have to do like x squared plus the y squared equals 1 squared. Subtract your x squared. And then square root. So the y is square root 1 minus x squared. Okay, they both have the same denominator. They also both have a radical 2 on top. So I'm just going to kind of manipulate this answer just a little bit. I'm going to put it over the 2, but I'm going to factor out the square root 2. And then it has x minus square root 1 minus x squared. This is not exactly how they have it written in the book. They like didn't rationalize the square root 2 over 2 and they left the radical 2 in the bottom. So it looks a little bit different, but that's how I would have done it. So the book answer looks like this. But it's got a square root of 2 in the bottom. So we rationalized it. All right, example 5, proving cofunction identity. So this is an identity that was in our big list of identities already. We're going to prove it by using cosine difference formula. So the cosine difference formula says we're going to do cosine of pi over 2 times cosine of x plus sine pi over 2 sine x. So cosine at pi over 2 is pi over 2. Cosine at pi over 2, here's pi over 2. What's cosine? 0. Multiplied by cosine x. What's the sine at pi over 2? Multiplied by sine x. So 0 cosine x is 0. Plus sine x is sine x. Proved. So this is an identity that we've already had in our list of identities. We just proved it by using the sum and difference formulas. Okay, deriving a reduction formula. So we're going to simplify each of these expressions using the sum and difference formulas. So this would be a cosine difference. So we're going to do cosine theta, cosine 3 pi over 2, plus sine theta, sine 3 pi over 2. So cosine theta, let's see, cosine at 3 pi over 2 is 0, plus sine theta, sine at 3 pi over 2 is negative 1. So the expression cosine theta minus 3 pi over 2 is simplified to be negative sine theta. So if we were doing something that had this expression in it and we wanted to make it a lot simpler to deal with, we would replace it with negative sine theta. Same thing with tangent theta plus 3 pi. So now we're going to try a tangent question. Let's see how that simplifies down so we could have something easier to use. So the tangent formula for plus says to do, I think it's plus on top. Let me just double check. We're going to do tangent u plus tangent v, and then it's minus on the bottom. So it's going to be tangent theta plus tangent 3 pi over 1 minus tangent theta times tangent 3 pi. So we've got tangent theta plus, does anybody know the tangent at 3 pi? It is 0. And then we do 1 minus tangent theta multiplied by 0. So I get tangent theta over 1, which is tangent theta. So if we're asked to find tangent theta plus 3 pi, if we use our sum and difference formulas, we can simplify that down. It would be just tangent theta. So far, this is just plugging stuff into a formula and simplifying. Okay? Not too much thought process going on here. Application from calculus. Yay, that sounds fun. It says verify that the left side equals the right side. So I am going to work on the left side. I'm going to leave my right side alone, okay? I'll leave that side alone. Since it says sine x plus h, this part right here, I'm going to use the sine sum formula, which is sine x cosine h plus cosine x sine h. So now I'm looking at the right side and I see a cosine x with a sine h. So looking down at my first step, I see a cosine x with a sine h here. You see how these terms kind of match each other? I just haven't divided by h yet. So then I'm looking at these two terms, and somehow those have to go together to make this. So I'm just going to rearrange this really fast. I'm going to put cosine x sine h over h plus sine x cosine h minus sine x over h. So I just rearranged it a little bit. This purple one is this one here. Oops, it's not purple. So if I unmultiply the cosine and sine on the top, the h can only go with one of them. This would be like h times 1 on the bottom. The h can only go with one of them. So it's going to go with the sine. So it looks like that one. Cosine x times sine h over h. But how am I going to make the next one look correct? I've got sine that I can factor out, sine x, and then I have cosine h minus 1 over h. But that's different than what they're asking me to do. What were they asking me to do up there? What up here is different than what I just did? Did they factor out a sign? What did they factor out? Did they factor out just a sign like I did? Or what did they factor out? See how they have a negative sign here and I don't? So they actually factored out a negative. So I'm going to erase and just rearrange this a little bit. They factored out a negative sign, which will leave us with a 1, a positive 1, and a minus cosine h. I just reordered it as I was pulling it out. We could have reordered it here too. I could have written negative sine x plus sine x cosine h. So I could have rewritten it there too. Well, I guess they don't have the line the whole way either. There. So we're just using these new identities to replace stuff and manipulate things. Last example, example 8, solving a trigonometric equation. Find all the solutions of sine x plus pi over 4 plus sine x minus pi over 4 equals -1. What could we do? Any ideas? Gracie, you got an idea? We could use the formulas. We've got the sine sum formula and then the sine difference formula. So let's use those. So we'll have sine x cosine pi over 4 plus cosine x sine pi over 4. That's the first part. The second one would be sine x cosine pi over 4 minus cosine x sine pi over 4. Barry, what could I do next? Oh, you know what? That's a lot of writing. I think I could do something else first that'll avoid me doing all that writing. But I am going to do what you're saying. I just don't want to do it yet. Like, there's some like terms up here, aren't there? Let's see. This one with the subtraction, minus cosine x sine pi over 4. Well, here's plus cosine x sine pi over 4. So those are going to cancel each other out. And then I've got this, and I've got a second one. So I've got like terms. There's 2 of them. So 2 sine x cosine pi over 4 equals -1. So now I'll go ahead and do the pi over 4 because I don't have to do as much work. 2 sine x multiplied by square root of 2 over 2 equals to -1. So we got to solve for x. Philip, what can I do? I got to isolate x. Divide what? Sure. Divide each side by 2. That's going to cancel that too. Madeline, what should I do? Well, I got to get x by itself. Divided by what? Say it again. Yes, but I don't divide by fractions. So instead of dividing by a fraction, I'll multiply by its reciprocal. So, yeah. So I get sine x is equal to negative radical 2 over 2. So now we're finding what x is equal to. By the way, did this give us, oh, it did give us an interval. Just checking. It does tell us to do it on the interval from 0 to 2 pi. So sine is negative in the third and fourth. What would be my solutions? Be 5 pi over 4 and 7 pi over 4. Okay, so just to go back to our module for today, which I don't even know if it's still open. I don't think it's still open right now. So our module from today does have the 5-4 on it, but it also has 5-5. We didn't even get to start 5-5 today. So you will have time in class next time to do 5-5. And then you're going to notice, I don't have my module open right now. Oh, maybe I could do it this way. I just didn't want to show you anything from some other class that's open. So there's a lot written on this because honestly, I had no idea how long the Desmos thing would take because I hadn't done it before. So we only got to this assignment. All right. But after that, so next class, we will continue with our 5-5, and then you'll have an assignment. But then there's another like 2 assignments after that. And then it says all assignments are due 11/24. That does not include 5-3 that was supposed to be due today, but I screwed up and didn't have my thing up, and then Cami didn't work. So that does not include today's, that 5-3. That it's starting today, 5-4 and 5-5. All these assignments will not be due until that Tuesday, 11/24. Some people asked what we're doing on that Tuesday. We're going to be reviewing for like a chapter test. So if you are going to be gone, you're going to miss review. You won't be missing a test. Yeah.
So are we doing 5-5 notes in class tomorrow or 5-5 problems?
So what I said on here was you will watch the video and then work on 5-5 in class. So you know how normally we have like 2 things we do per day. So what I would prefer is that you would get your assignment done, watch the video. Video's not up yet, so can't watch it yet. Literally creating 5-4 right now. That way you can have your whole time to work on it and ask questions. If you don't watch it, you're going to come to class and you're going to watch the video because I'm not going to teach some people when some people have already watched it. I want to be available to answer questions. That's what I really want to do, is just be there for you to answer questions. So again, one more time, your assignment, this is the only page. It's not due till Tuesday. Don't put it off. And then you'll just watch the next video. That next video is not going to be up till late tonight or tomorrow because I have not created it yet. Okay, but it'll be up. I will create it tonight unless Cammie's well, I guess I could create the video still. So I'll create that tonight, okay? Thank you for asking. And then I have your book links at the very bottom.